section 9.6 has got kind of a hodgepodge of topics. They all blend together in their own way. We're going to talk about the Pythagorean Theorem, the distance formula. I'll even throw in the slope formula for free. And we'll start by talking about Pythagoras. Pythagoras himself was kind of a unique character. He started a school of mathematics, which really derives from a Greek word meaning science, centuries and centuries ago. And one of the most famous things that he's known for is the Pythagorean Theorem. So this applies to right triangles. Now, as far as right triangles are concerned, what does it mean to have a right triangle? What does this little square here represent? Yeah, it's a 90-degree angle. So if you have a 90-degree angle, then hey, that's a right triangle. You can only have one right triangle. Now, if you do have a right triangle, then the sides of the triangle satisfy this relationship. A squared plus B squared equals C squared. Now, side C is opposite your 90-degree angle. And that has a special name. Does anyone know what that thing's called? Good. It's called the hypotenuse. So, yay. Now, the word hypotenuse itself comes from an Egyptian word which reflects how they used to do some measuring. In fact, you remember the Egyptians engineered some great pyramids. They did so in part by having a knotted rope, and if you stretch this knotted rope across, say, a building that you were trying to erect, and it matched perfectly, that is, you had, say, 3 dots on one side, 4 on another side, and 5 on this side, then this angle had to be a right angle. Now, the person that did this was called a Hypotenuse, and they were the engineers of ancient Egypt. So that's this guy right here. He was the Hypotenuse. These guys were his underlings or servants. And in the process of doing this, process of checking this angle, you're stretching it. And the Greek word for stretched against is where we get the word hypotenuse. But enough history here. Let's get back and work with the Pythagorean Theorem. See if we can't practice it and learn it a little bit. So what's going to happen quite often in these types of problems is you're going to be given a little bit of information and asked to solve. So problem number 16, for instance. So this is section 9.6. Problem 16, they tell us that A is 5 inches, B is 12 inches, and they ask us for the length of side C, basically the hypotenuse. And you can assume that your triangle is in this form, A, B, and C. C is going to be the length of the hypotenuse always in these types of problems. All right, well, let's check it out. Accordingly then, 5 squared plus 12 squared equals C squared. So that's going to be 25 plus 144 equals C squared, or 169 equals C squared. What do you square to get 169? Or, put it another way, how do you solve for C? Good. So, to solve here, you're going to take the square root. Now, technically, there's a plus or minus square root because there's two numbers that you could square to get 169. You could square positive 13 or you could square negative 13. What's wrong with an answer of negative 13 here in this case? Yeah, you can't have something that's negative 13 inches long. So, thanks, Jared. In this case, C equals 13, but please don't put just 13. It's 13 inches. And I do want to see the units, please. Okay, so not so bad. What else? Let's try a different one. Are we okay with that first example? Should be a nice warm-up example. All right, good. Let's try problem number 18. A is 24 yards. B is 7 yards. And again, we want to find C. So let's see about this one. 24 squared plus 7 squared equals C squared. If you don't have a calculator, maybe you should borrow one. So come on up and borrow one if you need to. Definitely, maybe not on the next one. Maybe on the next one. You will need a calculator, or at least appreciate one. Everyone's all set for calculator devices? All right. So I believe that 24 squared is 576 plus 49 equals C squared. So 625 is C squared. If we take the square root on both sides, and we're just going to focus on the positive square root here because the length has to be positive, what's the length of the hypotenuse in this case? Good. 25 yards for the hypotenuse. Now, you don't always have to solve for C. You can solve for other sides. For instance, problem number 22 looks like this. A equals 14 inches. C equals 15 inches, or 50 inches, I should say. The question is, what's B? Well, let's plug it in and find out. You're going to get 14 squared plus B squared equals 50 squared. Well, 14 squared is 196 plus B squared equals, what, 2,500? What are we going to do to solve for B? Subtract. All right, so subtract 196 from both sides. B squared equals 2304. What does B equal? How many? 48 inches. Good. B equals 48 inches. Now, just a quick reminder here. If you were doing this on your calculator, we need the square root of this. My personal favorite trick in getting the square root is to recall that the square root of something is really something to the 1/2 power. So if you hit the up arrow key on your graphing calculator, it's going to take your previous answer and raise it to a power. So since the square root is something to the 1/2 power, I'll just raise it to the 0.5 power. So you get a quick square root that way of your previous answer. 48 inches. Let's turn to your handout. Let me tell you a little story. A friend of mine years ago, his name is Jim Dodge, called me up one morning on a Saturday and says, "Hey, I'm going to rent a plane this morning. Let's go up north and pop in on one of the casinos." I'm like, "Sure, it's pretty cool." So we flew into a airport near Manistee, and on the way back, he's like, "Hey, this is cool. We're exactly 5,280 feet in altitude. What's special about 5,280? It's exactly 1 mile. So we're exactly 1 mile above the surface of the Earth." I'm like, "Hey, that's kind of interesting." Yeah, kind of cool. So I wondered to myself, I'm like, gosh, I wonder how far we can see to the horizon. So the Earth is about 3,960 miles. And that 3,960 miles in radius is here. And then 1 more mile above it. So the question is, how far to the horizon? That is, what's the length of that side? So the picture looks like this. 3,960, 3,961, and D. Or you can call it H, whatever you want. But we want to find the length of that side. The reason this is a right angle is because you're not going to be able to see anywhere beyond that line of sight where your line of sight touches at a perpendicular to the radius of the Earth. So, that's assuming everything is smooth. This is an ideal calculation. But let's figure out how far you can see. So that's a Pythagorean Theorem problem. Give it a shot. Right here. Now, if you're watching this at home, you should also try it at home. And I have the video paused while I let you guys give it your own try. For some reason, the software that we have here, they wanted like $800 to configure it. And our IT department said, no, which I don't blame them. I wouldn't have paid it. But I don't have a pause button because of that. What surprised me about this is that it worked out to be a nice even number. That's why I remember this problem so well. It's because, like, hey, the numbers worked out pretty good. So let's see what you're getting. You should set something up like this. 3,960 squared plus D squared equals 3,961 squared. Now, we can actually do this one without a calculator, which is kind of cool. But you know what? Let's just do it on a calculator. So 3,961 squared. How about if I do the squared key? There we go. Squared minus 3,960 squared, and then I want the square root of that. So that's 7921. And what's the quick way to get the square root here? Yeah, raise it to the 0.5 power. Raise it to 0.5 power. Bam. So D equals 89. What are the units? Yeah, 89 miles. So about 90 miles. In the ideal world. So pretty cool. Are you comfortable with the Pythagorean theorem here so far? Let's try one from the book. It's problem number 24. So they give us a triangle that's kind of a special triangle. It's called a 45-45-90 triangle. So let me draw that triangle for us. And we'll work through the problem. Here. And here. So this is our 90-degree angle, 45 and 45. We got one side, which is 32.10. Another side is called X. That one's called H. Now, I guess the thing to know about a triangle like this is that if it has two angles like this that are the same, then the opposite sides are the same. So you pretty much get this side for free. That's just 32.10. So the last part of this then is to find h. So what would you do to set up something to solve for h? How can we solve here? What equation should I write down? Good. Yeah. Thank you. So 32.1 squared plus 32.1 squared equals h squared. So I'm going to do this 2 times 32.1 squared instead of typing it in twice. And I want to raise that to the 0.5 power. And I get about 45.40. 2060. Bless you. Now, one thing that I do quite often is I ask you to round your problems to certain values. And if I ask you to round this to the nearest hundredth place, we'll use a little approximation here. Approximately speaking, what would h be to the nearest hundredth? 45 point what? 4 or 40? Which one should I write? 40. If you're rounding to the nearest hundredth place, there has to be something in that decimal place. 0 or not doesn't matter. There has to be something in the hundredth place. And let's see, I don't think they give us any units, so we're good on that one. Problem 78. I believe OSHA. Does anyone know what OSHA stands for? Yep, Occupational Safety and Health Administration. I believe OSHA probably has some guidelines as to how far away from a wall you put your ladder. And, you know, it makes sense because if it's too close, then, well, you know, it's not as safe. You want to make sure that you're leaning against the wall enough so that the ladder is not going to move on you, assuming the base is secured. In any case, let's see if we can't figure out if this ladder is tall enough to reach the height of a 35-foot ledge. So we want to figure out the length of... Yeah, I'm sorry, it's not showing up too good. Let me try it this way a little bit. There we go. So we want to find the height of this and figure out, is it tall enough to reach a 35-foot high ledge? Okay, let's see. $78. So I've got a graph that looks like this. $9, $37, and H. What are we going to set up for this particular problem? What's the equation? Janika? What will that one look like? Thank you. So, let's see, there's going to be 81 plus h squared equals 1,369. So subtract 81. H squared equals 1288. And I want 1288 raised to the 0.5 power. So I get 35.88. Dot, 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 dot. But that's not where the problem ends. The problem ends with a yes or no. Is this tall enough to reach a 35-foot high ledge? Now, it's more than 35 feet, right? So, yes, it is tall enough. Nice, nice. Any thoughts on the Pythagorean Theorem? You okay with those? All right. Well, let's move on to the midpoint formula and the distance formula. So, I'm going to grab one of these. So, the midpoint formula. With the midpoint formula, you're trying to find what's in the middle of 2 points. And I've got one graph for you. We'll solve it in a minute. But you got 2 points, and you want to find out, all right, well, gee, what is in the middle of these two? If I drew a line between these 2 points, and I wanted to find exactly what's in the middle, where would I put that center dot? How do I find those coordinates? Well, really what you're going to do is kind of average these things. So, it reminds me when I sold my first car. I was asking 800, or I was asking 900. The person that wanted to buy it was offering 800. Where do you think we ended up? 850. Yeah, in the middle. Now, to find the middle, you add up the two numbers and divide by 2. And that's what you're going to do with your x and y coordinates, is average them. So you're going to add them and divide by 2. So your midpoint formula looks like this. The midpoint of these 2 points is going to be x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So there's your midpoint formula. You're averaging them. Now, it's important to kind of keep this one straight because you're going to deal with several other things that are going to have similar x1s and y1s, x2s and y2s, but this is the only one that's going to have an addition as part of it. The other two are going to have subtractions, like over here for your slope formula and down here for your distance formula. Well, we'll practice it with this one first. And I think that one's actually problem number 48. So if we want to label this one as number 48, that's great. You don't necessarily have to draw these things in order to do them. This is your x1 and y1. This is your x2 and y2. And let's just average those. See if we can't find what the midpoint is. So what 2 things am I going to add in the x position? What numbers do I need to put in? Thank you, 2 and 10. So 2 plus 10. Someone else for the y position. What am I going to plug in there? Thank you, negative 2 plus 4. So that gives me 12 over 2 and 2 over 2. I do want you to simplify that down. We end up with 6 and 1 for the coordinates of our center, and that makes sense. That's exactly where I drew this point, 6 and 1. So, looking pretty good. It's the midpoint. It should make sense. If you were to draw it, you don't necessarily have to draw it. That's okay. But let's practice a couple others with the midpoint. We're okay with 48. Let's try 46. For problem 46, no pictures, sorry. We're going to have negative 5 and negative 2, and 7 and 3. So we want to find the midpoint between those two. mind, your answer should make sense. If you were to graph it, it should look like the midpoint. Billy, what should I put in for the first one? Thank you. -5 plus 7, and good. Let's simplify this. That's going to be 2 over 2 and 1 over 2. 2 over 2 doesn't simplify anymore. I do hope that you simplify 1 over, or 2 over 2. Yeah, 2 over 2 does simplify. 1 over 2 doesn't. So 1 and 1/2. Thanks, Billy. I think the hardest part about this one is just to have it memorized. Just to have the formula memorized. You want to keep it straight from, say, the slope formula or our distance formula. That's the hardest part. This one's going to be unique amongst the three formulas we're going to have because there's two answers. There's an x and a y coordinate. Do you want one more with the midpoint? Sure, 52 then. 52, -3, and 5, and -5, and -5. I'm kind of cheating because really this one's supposed to be a distance formula. So we'll go back and solve it with the distance formula. Right now we're going to find the midpoint. So let's go back over here. What'd you get on this one? Let's see. 5 plus -5. So the first case, thank you, -8 over 2 and 0 over 2. I hope both of those get simplified on your paper. -4 and 0. Let's see if that makes sense relative to our graph. Oops, I want to do it there. Right there. So let's check out -4, 0. And does that look like it's midway between the other two? Yeah, it looks pretty reasonable. I'd say so. Okay. Now there's another thing we're going to do, which is really the way problem 52 was written, which is to find the distance between these 2 points. That is, how far would you have to walk if you're walking from one point to the next? So that distance formula actually comes from the Pythagorean Theorem. Let's take a look back at our handout. So what did the Pythagorean Theorem say? Well, if this was, let's call this D for distance, and this is A, and this is B, then we know that the Pythagorean Theorem says A squared plus B squared equals D squared. If you wanted to solve for the distance, then you could take the square root on both sides and get D equals the square root of A squared plus B squared. You don't have to necessarily follow the derivation of this. You don't have to memorize it anyways. Hopefully you can follow it. But we've got expressions for A and B. And what that gives us is our distance formula is going to be the square root of this side, which is x2 minus x1 squared, plus the square root of that term, which is your y2 minus y1, and I'm plugging that in for b squared. So even if you weren't fond of the demonstration here, that's okay. It's this formula that you have to know. That's your distance formula. So that's two formulas that you have to have memorized so far. There's the midpoint formula, which is right here. We've got the distance formula, and then we'll finish up with the slope formula. Slope is not necessarily explicitly part of this section, but I put it in here just because it's all relevant. So the distance formula is this, and let's apply that to a couple problems. And we'll start with now we'll start with problem 52, what we just did. Problem 52, like I said, was really a distance formula problem. So going back to those particular points, it was -3 and 5, and 5 and -5. Or excuse me, no, -5 and -5, right? Yeah, there we go. -5 and -5. So this is your x1, y1, and this is your x2 and y2. If you switch the points, it doesn't really matter. It doesn't really matter the order that you put in x1 and y1 and x2 and y2, as long as you subtract the x's and subtract the y's. So the distance is going to be the square root of x2 minus x1 squared. So -5 minus -3 squared. y2 minus y1 squared. So -5 minus 5, again, squared. You have to be careful here with the double negative. What happens inside the parentheses? Yeah, it's -5 plus 3. And what's -5 plus 3? -2. So -2 squared plus -10 squared is the square root of 104. Because you get 4 plus 100, 104. Ethan, something not looking good there? Okay. Now, there is a little bit of bonus work we can do on this one. You might remember splitting up our radicals like this in an earlier section in chapter 9 here. That's going to be, what, 4 times 26. What's the square root of 4? Good. 2 square roots of 26. Yes, I do. Now, I mean, if you get this far, hey, that's a good portion of the credit. Okay. Even filling in the formula is partial credit. But you know, the farther you get, so I'd say 1 point, 2 points, and 2 points. You know, something like that. So it's definitely worth it to get all the way. But even if you can't get all the way, get at least this far. Get as much in terms of partial credit as you can. Let's try another one. This time, well, we'll actually go back and do problem number 48. We'll see if we can't find the distance. How far would you have to walk to go from this point to this point? All right, well, So we've got 2, -2, and 10 and 4. So that's your x1, y1, x2, and y2. See if you can't fill in the distance formula on this one. x2 minus x1 squared plus y2 minus y1 squared. This one should simplify pretty easily. Should work out nice and even. Lily, what should I fill this in with? What's that going to look like? No. Good. 10 minus 2 squared. 4 minus -2 squared. Nicely done. So that's going to simplify to 8 squared plus 6 squared. And like I said, this one works out nice. You get 64 plus 36. Square root of 100 is 10. So the distance between those 2 points then, if you were to measure it out and walk it from point to point, is a distance of 10. Yeah, we use these numbers. Yep. So we've done a couple things with these numbers, and what I'm eventually going to do is I'm going to give you all 3 of these different formulas applied to these points. So we did the midpoint, we got 6 and 1. We did the distance, we got 10. Last thing to do is to do the slope of this line. So, you know, I don't think you're going to have to worry about units in these very much. No. Yeah. Yeah, it's just based on coordinates. So there's no units that are really given, so it's unitless. I mean, you could work with units. In fact, one of the applications for distance formulas is I think a lot of applications for the distance formula. Let me see if I got something here on that. That's the math stuff. No, just search for it. Distance formula. There you go. So you can use it in facial recognition software. At least this is kind of an old school approach, is to make measurements on somebody's face and look at key distances to try and recognize somebody. And of course, what the big thing nowadays is to meet your love of your life online, right? So compatibility. And what they do is you answer certain questions and they look at how far apart your answers are from somebody else's. Now this is kind of, in a very simple case, down here at the bottom, you see that you can do this, you can extend the Pythagorean Theorem for lots of different answers, or distance formula for a lot of different answers. And you're trying to minimize that distance. You want to be close to somebody. Now, companies like Tinder and Match.com probably have something a little bit fancier on this. They weight it a little bit so that these distances, some of them are important. You're like, oh, it's really important that this person works out or doesn't smoke or something like that. So you would weight it differently. So you put a little coefficient in front of this. to reflect the importance. Of course, MapQuest, they have to use the distance formula at some point. I mean, they just have to. So definitely a lot of applications for the distance formula, and that's just kind of scratching the surface a little bit. Okay, back to here. Do you want one more with the distance formula, or can we finish up with maybe the slope formula? Slope formula it is. Good deal. So slope formula just talks about, you know, how steep something is, how steep of a pitch. In fact, over the weekend, I was down at the Lexus Velodrome, and that was really, really cool. And if you look at the ratio of the rise to the run, actually it was a 50-degree angle on the bank of the wall that you're riding on. It was pretty intense. So pretty steep slope. But slope is the rise over the run. And if you put that in form of your x and y coordinates, that looks like this. The rise is going to be the difference in your y coordinates, so y2 minus y1. And the run is going to be the difference in the x coordinates, x2 minus x1. And the ratio of those two, rise over run, that's your slope. So let's see if we can't find the slope of a line between these 2 points. The slope of this line in particular. And that's going to be 4 minus negative 2 divided by 10 minus 2. So 6 over 8 or 3/4. So that's your slope formula. So we've got all three different types of measurements for these 2 points. We got the distance, which was 10. We got the midpoint, which was this coordinates, 6 and 1. And finally, we got the slope, which was 0.75 or 3/4. We're looking okay there? All right, let me give you some homework. For homework, try (15) through 23 and 43 through 61, the bonus problem of 75.